All right, we're back. It is COMP123, that's Programming 2 in the summer 2016 semester, and it's week 7, part 1 of our broadcast. And I want to do a little bit of a review for the midterm test that's happening on Friday, right? All right, so I guess the best way to start with this one would be to actually look at what we've done so far, right? So really, we started off with advanced methods. So stuff to know, and if I was going to go through the PowerPoint with you guys to know what I'll do with you. Should you care about certain things in advanced methods? Let's take a look at stuff. Highlights the things that I will get you to do, right? And also, remember that there will be classes on the test. I mean, that's just the way it is. If I don't build the class or some kind of abstract class, that kind of stuff, then we wouldn't miss some stuff. We would miss things. But when I talk about abstract methods, these things here, methods, whether you're using them in a static class like the driver class that we started off with last semester. Remember when you guys didn't have classes at all, right? Where everything was in one file. Methods have different signatures, so you need to know about them. Am I going to get you to use ref and out for the test? No, I'm not going to get those ref and out. Reference and out type parameters. I probably will not get you to do those things. So please don't sweat too much about this stuff, right? Reference and out parameters. You should know about them. You should know what they mean, but it doesn't mean that I'll get you to practice them on a test. Parameter array, same thing. I probably won't get you to. I won't bother you about that whatsoever. So things not to study is more what I'm telling you not to do. Overloading methods. I might have you make more than one constructor method, right? Which will basically be like overloading a method, right? Whether it's a constructor method or whether it's a regular method, right? Chances are you may have to create more than one constructor. And remember, when we talk overloading methods, we're talking about stuff around different method signatures. I love the music. It's fantastic. It's okay, Rufik. It's all right. I forgive you. No problem. So at the end of the day, the way it works is this. If I have an overloaded method, it's all around the method signature, right? So your method signatures have to be different. And here's an example of basic, static methods that are part of a driver class here. I'll make this bigger for you guys to see. We've got two methods, right? Here's the main driver class, right? So again, there's no class here other than the main driver class in this example. And this is, I'm on slide 26 of the first PowerPoint presentation we did like week 1, right? So display with border and display with border, the same name, right? Different signatures. So that's what you have to know about overloaded methods. And I'll probably get this to be a constructor. That's probably what we'll get you to do, which constructor is like an overloaded method with different signatures. Okay, so those kind of things. What else? Overload resolution. I'm not going to talk too much about that, only because there's just so much to talk about. Like, I mean, really, there's so many aspects of the test that we can go over, and it's nonstop, right? This optional parameters, guaranteed, will be on the test. Please study this piece, right? So if I go over to what are optional parameters? Who remembers what they are? Right. Actually, you allow default values, and the idea with if I create an optional parameter list, right, for a method, here's my display size, and I go length, width, and height, and the default height here is 1. I actually assign it inside the constructor signature, right? So the signature of the method signature, right? So whether I do it in a constructor, whether I do it in another method or whatever, and I'll show you some of the examples today about this, definitely you'll have to hit some kind of, you have to understand the order. Remember that you cannot have optional parameters. I can't put this one ahead of these ones because these are not optionals. These are required because there is no value set for them. The only way you can do it is if it's required, and then optional, right? Optional has to come last. So the one that's, when I say optional, I give a default value, in this case 1, right? It's the order that you put them in. When I give a default value, I can choose, it's more flexible from a method signature perspective. I can choose to put a value to that parameter or accept the default value that I've already given it in the signature. That's the option, right? So it makes my method signatures a little bit more flexible, right? Instead of creating a constructor signature with an integer and a string, and then as an example, and then just an integer, I can make an integer with a string with a default value, and that's exactly like what I would be doing with an overloaded method. All right, so I could have one method, but two ways of using it, right? And that's pretty cool. That's like, that's a really cool way of doing it. I'm going to show you some examples of that in my little example player thing we did last week or so. So optional parameters, and they tell you there's some really cool examples of what works and what doesn't. Like an example in this one, it's not valid because the optional parameter is in the middle. You can't do that. You have to have, required parameters, and then the last one, or all of them are optional. That's another valid one. You have all of them are required. That's also another valid one. Invalid because you can't do an optional and then two required. So you can't do that. The optionals have to come last. Okay, so that's something to know. Leaving out unnamed arguments. I'm not going to talk about these kind of things too much. And I'm just scooting through the PowerPoint to make sure that we hit all the requireds that you need for the exam. That's all I want to do here, right? So I'm not going to go through everything else. Okay, so that's really in a nutshell. That was week 2. Okay. Week 3, we talked about classes, right? And this is a big one: objects and classes. You need to know about these kind of things. Here's something I won't do. I'm not going to test you on unit testing. We won't talk about this again till next half of the semester. Only because I wanted to introduce it to you so you've been exposed to it. That was the idea there. So it's not like you've never seen unit testing before. We haven't had a lot of chance to do it because of all the other stuff we're doing here. But it won't be part of the test. I might give you a bonus, just like we do for our assignments, but it won't be part of the test for you to do a unit test. The other thing is, from a class concepts perspective, you should know how to construct a class. You should know that the classes are supposed to be in their own separate files. You can certainly construct a class with the diagram if you choose to do that for the test. I'm totally cool with that because it's just another way. All you're doing is you're creating a framework that you're going to hang all your code on, right? That's what you're doing with the diagram. The diagram does not complete everything for you. It just creates a framework, a shell for everything, and then you just fill everything in. And I'm okay with that. You can certainly do that. Understanding how you can create constructors. What's the difference between a constructor and a regular method? That it has the same name as the class. That's important. The difference between when we create a good class, the idea of information hiding, all right, which is private instance variables, public properties, understanding how to do that. You should understand how to make properties. What's the difference between an instance variable or field and a property? Properties of getters and setters. You should know about those kind of things, and instance variables. Those things are, you should know how to do those. You should know how to read my assignment. If you know how to read my assignment document by now, you should be able to read line by line, because my exam is going to look like an in-house assignment. Again, it'll be billed for 90 minutes, right? So everything you need to do, you'll have to do in 90 minutes. So it can't be large, right? Because we only have 90 minutes for you to plug stuff in. You'll get a template that you're going to work with, so it's not like you're going to work from scratch. So I'll have some basic files available, and chances are, you build everything up from there. Okay. When you create objects, remember when we talked about classes as a blueprint, objects are really an image or a clone, almost like a concrete thing that we create from the class. We have our blueprint, let's say a blueprint of a car or a house, that whole analogy again. And then when we create an object of the class, we create an actual house or car from the blueprint, right? And the other thing to notice, each object, going back to classes and everything else, each object is unique. So even though we're using the same blueprint class, right? Each object has its own parameters, its own data. It's completely different than every other object, even though there is a relationship with the class. It is a house, if I was going to go with the house, right? And I'm doing air quotes here so you understand what I'm doing. But that's the relationship that each object would have with its class. It has an is-a relationship, right? Another thing to note is that each class or each object is a reference type. And the difference between reference type and value types. We're also going to talk about lists today a little bit. Lists are also reference types, right? Not value types, because lists are a complex object, a complex data type, right? It's not a simple data type like an integer or a float or a double or something like that. It's not like that. It is a complex data type, like an array, as an example. And so therefore, it's a reference type, not a value type. And if that's the case, we only really need a getter. We only need a getter for our, if we include a complex type inside of our class as a field, we only need a getter. We don't need a getter and a setter. Why? Because if I get the actual object, I can apply its built-in methods, right? And I never have to set an object to another object, typically. So I could make the the property for a complex object like a list or an array or something like that. I could make it as a read-only property. I read the value. I can actually play with the value, but I can still do stuff. I can still add things to it and everything else. We'll talk about that today as well, right? So I know that's kind of confusing. It's a confusing aspect of this, reference types versus value types. The other thing is passing objects to methods. We'll look at that today. Like what about, okay, I have, in my last example, I had the player and the enemy, right? But both were game objects. They're both game object types, right? I can pass the player or the enemy, but in my method, I'm going to listen for a game object. Why? Because both player and enemy are both game objects, right? So I can listen for those things. And then I can determine their type. We'll look at that, right? So an example of that would be here. If you look at this, this little slide. So we have display employee data, right? And notice that I'm passing in an employee type, right? Which is emp. So this is the static method that I'm passing in there, right? And notice that when I call display employee data, right, I'm actually passing in a worker, which is an employee, or another worker, which is also an employee. Here, it doesn't care, this method doesn't care what I'm passing, what kind of variable it is. I don't know which one I'm passing in. All I know it's an employee. So this is the way you can do that. You can just use the employee data type. This is like we're using employee as a data type, like a string or an integer or a float or whatever. And that is almost like what we talked about before, which is I'm using objects, right, to construct my other classes and everything else. So-called class composition. I'm constructing stuff. I'm composing everything from existing objects, right? As opposed to using inheritance, which is less desirable in a lot of cases. And we'll talk about that. It solves some problems and creates other problems. All right. The idea of properties, there's two types. There's read-write properties with a getter and a setter, and then a read-only property that only has a getter. All right, so getter and setter properties, and then if you only have a getter, it's a read-only property. So if I say make a read-only property, for this on a test, as an example, then I only need the getter. I don't need the getter and setter for read-only properties. Okay. One of the problems when you do a C# test like this, and it's a in-house test or whatever, is there's a lot to know. We've talked about a lot of little things. Yes, you've been tested. I get those little theory tests we've been doing along the way, and a couple of assignments as well that you've been given. Actually, you get your third one. That's due when we come back from break, right? Which is supposed to get you to practice everything. So when we come to doing something practical, it's easier for you. You've done some practical stuff. To your detriment would be if you let someone else do it for you. If you work with somebody else and they did the bulk of your assignment, and even though I would give you your marks and everything else would be fantastic, on a test you'll suck, right? So that's really bad. So please don't do those kinds of things. Do your own assignments. Yes, you might get slightly lower marks, but then you'll have practiced, right? You'll have practiced, and when you go to the test, you'll be better. And again, creating properties. We haven't covered partial, where, or yield. We haven't covered those keywords, and we probably won't until we get into our UI stuff, right? We have covered these keywords: get, set, and value. Value is a keyword. When we assign a value to a setter, then we use the value keyword to pass data into, like right here, into the private instance variable or field called ID number. So there's private instance variables or fields, public properties. That concept, please use that in the exam. Okay, if you guys do public instance variables, you'll lose huge marks. Like, it'll happen. Like, I'll say, like, okay, you're not really doing what I'm asking you to do. Yes, you can solve your problem, right? but it won't be what I'm asking. The format will be incorrect, right? Remember that I'm going to ask you for structure, and one of my structure best practices we've been using is an underscore for all your private instance variables. Yes, it's our best practice here for our class. Is this something that we use outside the real world? Yeah, I do all the time, right? But there's some coding houses that don't use it. Same thing with the this keyword. The this keyword I'm asking you to use, especially on a test. Do you need to use the this keyword? No, it tells you it's not required, right? But please use it, right? Because it tells me how you're thinking. It tells me that you know what you're talking about. When you use the this keyword, you're saying, I'm pointing to this class, an object or a property of this class, not some other class. That was a weird little sound in my ears. Okay, so that's properties, how to create properties. Definitely going to be on the test, 100%. You'll have to create properties. Auto-implemented properties. I probably won't get you to do these, right? Yes, they're there and so on, and you can create them very quickly, but I'm probably going to get you to do fields and properties, which means you'd have to have both. I'm going to show you a really quick way today of how to make a property from a field. Don't tell anybody, because it'd be really bad. Other professors would get really mad at me, right, if I tell you these secrets, right? But I'll tell you how to do it, right? First you make a field, and then poof, you generate your property from your field, and it's just beautiful, right? But I'll tell you how to do that to save time for the test. That's what I want you to do to get higher marks. We'll talk about that today. They're really not secrets, actually. I'm just making it, and I'm just exaggerating, of course. But let's continue. So private, the idea of access modifiers, right? The difference between public and private. There's actually three that you should know. We don't use protected too much yet because they're still quite early in our object-oriented journey, right? But really there's three. There's private, public, and protected. Those are the major three that you're gonna have to use. I've used private and public all over the place in my examples, so you should have seen that. Private fields, public properties. Basically, if you make it public, it's accessible outside of the class. So when I create an object of that class, I can access the properties, or methods that I expose. If I make it private, I'm hiding that instance variable or even a method. I might have a private method that I only want to use in my class, like for example, the initializer method. It should be private because it's going to initialize on construction when my constructor is triggered, right? So that's a private method that I want to fire. I don't want to use a method that I'm going to expose outside. Initialize method. Why would I ever call the initialize method again? Probably would never be called again. It's only be called when I construct my object. So therefore, it's private. And there's other reasons to do those kind of things. And they show you some examples here of private instance variables and public properties. So I mean, you should know the difference between those kind of things. Let's keep going. This reference, I just talked about this, no pun intended. This refers to the context of the class itself, right? So if I use the this keyword as an example, let's see if they actually have something here. So I got return title, right? I could put return this dot title, right? Because what I'm saying is the title field belongs to this class. So therefore, it's another way to refer explicitly to a field that's in my class as opposed to implicitly. If I don't put the this keyword, I'm implicitly accessing that data, right? And C#, the compiler understands what you mean, right? Somehow, though, sometimes you get into a clash where the compiler doesn't know what you mean. For example, if I have a constructor that takes in a name property, a name variable, and then I'm assigning my name variable to the name variable, the name field that's inside my my class. If I go like name is equal to name, what does that mean? Right? It's kind of weird, right? But if I go this dot name is equal to name, you know that this refers to the name that's in my field, and name is the local variable that I'm getting into my constructor, right? So that's why we use this to clarify. For our class, I'm asking you to use this all the time because I want it to be clear in your mind what you're referring to. You're referring to the field. You're referring to the method that's part of the class, those kind of things, right? Not for any other reason, not because you need to do it, but I'm asking you to do it. Here's the example, right? So they add just this keyword in front. All right, so be prepared for that, this keyword. Constructors, will I ever make you use a destructor? No, but constructors definitely is another way of initializing a value for the object or values to the object and other things. It always triggers, constructors always trigger when an object is created right? So if I have an object class, as an example, that a blueprint of what I want to create, an example of that would be car. My class is called car. And then if I say my car is equal to new car, if I did that, when I use the new keyword, right, I'm using the constructor. I'm calling the constructor that's built into the class I've created, and that constructor method is triggered as soon as I create a new object, right? And they give you some really cool examples here about how to use it. So the same name as the class, that's important for you to understand. This is the empty constructor. We call it empty constructor or the default constructor because there is no parameters that this constructor takes, right? So if I say make an empty constructor, I mean this, no parameters, right? However, as you go through, if I take a constructor like this constructor has a named parameter called rate, right? So therefore, this is not the empty constructor, right? Once you do one of these, your empty constructor, it doesn't exist anymore. The default constructor exists for if you don't define any other constructors. That's the rule. So if I go here, and if I don't declare an empty employee constructor, and I go my employee is equal to new employee, automatically C# will create one for you, an empty constructor for you. That doesn't do anything. It's required, right? But once I define it like this, I'm overriding the default constructor, which is the empty constructor, and then putting in my own data. If however, I put in some kind of other constructor that doesn't have, it's not the default constructor or the empty constructor, the default constructor that the class would originally create for you is gone, it doesn't exist. And therefore, you can never use it. You can't say, I want a new employee with nothing, with no parameter passing. You have to, they would say, I don't understand what you want here, right? Because there is no empty constructor. Why? Because it wipes it away because you made a named constructor, right? Overloaded constructors, like I said, definitely you'll have to do something like this in your test, so something to study. And what does it mean? Different constructor signatures, just like we do different method signatures. Same idea, right? Using constructor initializer notation. For example, if I was to do this, you will have to do this for, as an example, for your, if I have an abstract class, is there going to be an abstract class on the test? Absolutely. Will there be a derived class on the test? Right? Like a superclass and a subclass? Absolutely. So you're probably going to have to do this to satisfy the constructor requirements from the abstract or superclass. Okay? So those are the things that will be on the test for sure. So this is, it's called initializer notation, and what you're doing is instead of using this, this actually just sends data. Initializer notation sends data to the constructor that fits. So example, we have a constructor that takes an integer, and we also have a constructor that takes something else, a zero. Zero could be a double, right? As an example, right? And because this constructor here only takes an integer, if I do this kind of initialization, what am I initializing? This constructor. And you can do that from the other constructors. Am I going to get you to do this? No. It's a little bit too complex, and you might get confused. But I'll make you use the base keyword, because the base keyword means take the incoming parameters that are coming into our constructor and send them to the base constructor, the constructor from the superclass. That you'll have to do, right? And you'll have to know how to do that. Ask me questions, guys, because if you don't understand that, that's a problem, right? What do I mean by base constructor? If I have a superclass, we'll talk about this in inheritance. An example of this would be the person class. And then my subclass is the student class, right? Subclass. And in my person class, I have a constructor that takes a name and an age, right? In my student class, if I have to have a constructor that takes a name and an age so I can pass it to my superclass. If I don't do that, it won't work. Therefore, I have to use the base keyword in my subclass to pass those two required values to my superclass. Unless I make, in my superclass, I make an empty constructor somehow, or I assign default values. Okay. Read-only modifier. Yeah, we're not going to do that right now. I'm going to keep going here. So we're talking about initializers, object initializers. There's a couple ways to initialize an object. Again, this is, if you look at the get and set, these are automatically generated properties, right? For height, width, and depth. And here, my box constructor initializes values that go into the height, width, and depth. I would use, in our example, I would use the this keyword. this dot height is equal to 1, this dot width is equal to 1, this dot depth is equal to 1. This is just object initializers, right? And we use the constructor for that as well. We use the constructor to initialize a lot of times. Okay, let's keep going down in here. Overloading operators. Would I get you to do this inside your in our test? No, we really haven't talked about them too much. I'll show you them today, right? But we really haven't talked about how would you use this, right? But I want you to think of it this. If I want to create an operator that's a plus for my custom class, like for example, we made a vector class. Hey, you know what? Why don't I launch this thing so you see what I'm talking about? So I've improved our little examples from last week, right? And by the way, all the code is up on GitHub if you want to follow along. But I want to talk about the vector class. I've really buffered it a little bit, right? So let me go to my player project here for a second and see what it looks like. And I want to look at the vector class. I've also created a grid. I want to show you what I've done. This is great examples for you. That's all I'm doing it for. I'm not making it so it confuses you, but rather just for example. So if I go to my vector class, you can see that the vector class has it has two private fields, right? Float x underscore x and float underscore y. This is where we store all our data for our class in our private fields. In our public properties, this is where we expose values, as an example, like x and y, and we assign it back. Now, why would I do this? This is like, I'm not actually doing anything extra in my public properties to assign stuff, but I could. That's the idea. That I could do other things here. When I assign something to my x and y values, I could do something else in here because I want you to always think about these accessors as accessor methods. Anything that's in the curly braces, that means I can add additional code in here before the return. I could add additional code in here before I assign. I could do all kinds of stuff in here, and that's why we use public properties, not just to expose what we want to, but also to have more control when we're assigning or ordering data. Okay, those kind of things. So here's our constructor for our vector. Notice how I have default values. This is an example of what you will see on the test, right? So here's my constructor. It's called vector2, same name as my vector2 object, right? Here it is. And as I go down, you can see that my vector2 object, what it does, it takes two floating values, an x and a y, right? And the default value is 0 and 0. So if I don't assign if I go new vector2, I automatically have x and y are 0 by default. Okay, and I do that by saying this x is equal to x, and I've already assigned my values. If I pass in something else, then it'll replace my default values with what I pass in. Okay, here's an operator overload. All right, and I created two operator overload functions. You guys haven't seen this kind of stuff, but I made it just for this for today, right? So I'm going to zoom in here so you can see it. Here's how the operator overload function looks. Here's my vector2. Right, I still got it almost looks like a constructor, except here's the differences. One, it has a static keyword in here. Two, my operator plus function, as an example, takes two vector2s. Here's my first vector2 and my second vector2. And what I'm doing is I'm adding the x's and the y's. So basically I can add two vectors together. Vector addition is what I'm doing here, right? Same thing with subtraction. Same thing with equation. I can say, hey, is this equal to this? Is my first equal to my second? And then when I do this, it automatically prompts me to make it not equal to. And how do I do that? I say, well, if in order for these two things to be equal, then the x's have to be equal and the y's have to be equal, right? And if for those to be not equal, either the x or the y has to be not equal, and then the whole thing is not equal, right? So you can use operator overloading by using the operator keyword and the kind of operator you want to overload. For example, the plus, the minus. Here's the double equal for for conditional equation, or not equal. Right, and so on, right? Will I get you to do this for the test? No. This is what it is, though. This is what it looks like. And you have an example that I put up on GitHub. So if you go to our lesson for this one, and again, you can use my code for the test. It's completely open book, right? Open internet, open GitHub, whatever you want. The only thing I'd ask you to do is don't listen to my videos when we're working. That's kind of weird, right? But you can, for an hour and a half that you're working on stuff, you can totally use all your resources. So notice that this one is COMP123, summer 2016, up on GitHub, and it is lesson 6. So if you look at that lesson, it has examples of operator overloading, overloaded methods, the whole thing that I put in here for you. I've also created some interesting, here's an example of a method that has default values. I created a magnitude, a default magnitude for my vector. So if you don't put in a vector, a value, you get a value automatically. And I've created some default methods called east, northeast, and so on, north, because I want to be able to move my vector one way or the other. I want to be able to move my position from one to the other by just choosing which direction I'm in. If I want to move to the north, as an example, then my x direction is going to be 0, so I'm not going to go right or left, but my y direction is going to be minus, so up. Because when you do computers, the top left corner of your grid is the 0, 0 mark, right? So I go over by x and down for y when it's positive directions. All right, so I've created some basic methods. If I run this thing, I want you to show you the program file now for this. Now again, this is a much more detailed example than what we had before, right? So I have something called the touching enemy, and in there I also created something called a grid, right? So my player grid actually has, I can define the grid as a 15 by 15 grid, right? As an example. And the 15 by 15 grid, think about it as like, you know, just positions on a map, right? So I want to position my enemy. Let's just do this for a second. I'll take these away for now, right? So I enabled all those functionalities, right, that we talked about before. I just didn't have a chance to do it in class with you, so I did it away from class to show you what it looks like. And I've also created a magnitude method, a utility method that just, you know, kind of can calculate the distance between two vectors. So I have these two vectors. What's the distance between them? It uses the distance formula, right? The square root of x2 minus x1 squared plus y2 minus y1 squared, right? That's what the distance formula is between 2 points in space, right? So I've created that magnitude formula here. So let's run this thing and see what it looks like. It looks like this. So here's my my player and my enemy on a grid, right, as an example. And what I can do with it is I can move my player and my enemy around on the two-dimensional grid the way I want. Here's my player 1, which is my touching enemy, and here's my player 2, or two objects, touching enemy and player. Notice that the attack defense values, I haven't really set those up. I have the name of the values. I have the initial positions. So my initial position for my touching enemy is 5, 5, right? And my initial position for my player is 1, 1. Let's see how that looks like on the grid. So 1 over, 1 down. That's 1, 1. And 5, 5 is, you know, 5 and 5 down, right? That's how it works. And that's how I've been. And I also find that the different distance between these two is approximately 5.656854 units, right? Because it's taking the distance between these two objects, right? So I was able to create this example for you so that way you can see more complex classes a little bit. Didn't take me long to do, but I've really fleshed out some of this stuff. Like for example, I've also created a grid system, right? So if you look at a grid, my grid itself is a list. It's a list, a string list, right? And it has both width and height values, so I can decide how big my grid is, right? And I say, look, here's my grid, and again, I'm using default values in my constructor. I can say, well, the default grid size, the minimum grid size is 2, right? Because that means because I don't want, I even check if my width is less than 2, I make it 2. So you can't make a grid that's less than 2 by 2, right? Because otherwise you wouldn't see it. So let's try this out. Let's see if I can change this up. And if you wanted to see how I use this, if I wanted to make this grid only 10 by 10, as an example, here's 10 by 10. I can make it smaller, right? And then if I press play, you can see that my grid is a lot smaller, right? My players, my enemy is still on there, but it's a lot smaller than it was before. It's only 10 units by 10 units down. It doesn't look proportional because my spacing is weird on my console, right? But really it is a square, 10 by 10, right? I don't have to make it a square, however. I can make it 10 by 20. Right, width would be 20 by 10. How about that? 20 by 10. There's the, you know, another way I can do that. So 20 by 10. How does this look? More like a square, right? Because of the spacing, right? But this is 20, you know, units by 10 units, right? So that I can make my grid any size I want, right? And then I can add my player and my enemy to my grid by an add child method. I created an add child method that belongs to the grid object. Right? So if I was going to look at my grid, I have two methods here. One of them is the add child method, which adds the grid into the position, right, the player or enemy, and it determines which one it is. By the way, I can use the default get type method, get type, and name the name of the type. If I just do get type, it's both player and enemy are of type game object, right? but I want to know the specific name, I can just use the name method, the name property of the getType method of my game object to determine if it's a player or an enemy. And if it's a player, I put in the P in the grid, and if it's something else, probably an enemy, I'll put the E for enemy. And that's how I get my grid designs. When I do this, that's how it knows where to put these two values, right? Because I use the getType name method to determine that. And I also have another thing called moveChild, right? Where I can add child and I can move child. And moveChild will actually move the player around the grid. So let's say, for example, my grid right now looks like this. And I want to move my player to the right 5 spaces, right, on the grid. I have a method that I determine how to do that, right? So if I go to Program, and if I go down to the bottom before I print the grid out, so I use the toString method to show the grid, right? But I want to move my my player to the right. I can do something like my player. So here's my green player dot, move, and I want to move right. Remember, that was one of the first things we made in my player is move right, move up, move whatever, right? And I can move it by a certain magnitude. I can say, how much do I want to move right by? Well, I'm going to move right by 5. And so that's what it's going to do. It's going to take the move right method of my player object, which goes back to, if I go back to my Solution Explorer, if I go back to my abstract class game object, here's my game object. And if I scroll down here, my game object has a move right method. So all players and enemies and all that stuff, they can move right, as an example. If I go back down here, you can see that move right is right here. And I baked in a default magnitude value of 1. So the minimum value of move, if I don't put a value in there, is 1 to the right. And then I use my default vector object, vector to east, and I also plug in the magnitude value to say whatever the magnitude value is, the default is 1, I'm going to move to the east meaning to the right. The way the compass rose works on the computer programs is that east is to the right, right? North is top, right? And east, when it goes to the right, if I look at that, east is 0, north is 90, west is 180. That's the angle that we're talking about. And I can determine the angle and all that kind of stuff here. I've done all those calculations for you. So if I move to the right, I'm actually moving +1x to the right, but 0y. I'm not going up and down. I'm just moving to the right, right? And that's what I'm doing here. I'm actually taking the magnitude, but I can plug in my own magnitude if I want to, and I can move as much to the right as I want. In this case, what I've said to the program is move 5 right, move 5 towards the east, right? All right, and let's try that out. So if I run it now, I can see that instead of it being here, now it's over here. It's right on top of almost right on top of the enemy. And if I want to move this down here, right, I can move 1, 2, 3, 4 down. As an example, I can try and move the player 4 down. So how do I do that? It's 4 back, actually, because forward is towards the top and back is towards the bottom. So I can do that. I can say green player dot move back. Now I want to move back by 4. Let's see if I'm right, if it works. So I can move that player. So I can move my player, my enemy around the grid anywhere I want, right? So again, this is the beginnings. And by the way, I got some output here that tells me the green is moving right, and then green is moving back, as an example, right? It tells me where my current position is, my new position, and these position numbers are inside my list. My list is a big list. It's not a nested list. It's not a list of lists or anything like that. It's just one big grid, if you will, right? One big list. And the way I've printed it out here is I say, hey, depending on my width and my height, I'm gonna, every time I go to a certain width, if depending on how width my height, I add a carriage return or a new line character, so it goes to the next line. But actually, it's one big long list, right? And me figuring this out is creating a method that basically takes x and y and converts it to a number that I can. So I've done it for you, not because I want to confuse you, but rather just to give you some examples of more complex objects here. Also notice the direction is an angle. My direction, the touching enemy, as an example, is looking at the player. Here's where it's facing. Actually, it's facing 0, 0, right? I'm not facing the player. And the angle that it's looking at initially is 135 degrees, right? So it starts from 0, goes to the 90, and looks to the left, 135 degrees, right? And my player, as an example, is initially looking at 5, 5. That's the position it's looking at. So down and to the right, right, in the south eastern quadrant. So it's going to be 90, 180, right? And then it goes to 235, and then from there it goes to 315, which is down here. And so it's looking down there. So I can tell you the exact angle that my player is looking at, right? And so I can move him forward or back or whatever based on where he's going. I haven't done that yet. I haven't implemented that, but I could. Is it easy to make a framework like this? Absolutely not. It takes time and effort and hours of testing and everything else. Do I expect you to do that for a test? No. Do I expect you to understand some of this stuff? Some of it, yes. I expect you to understand some of it. Will I include anything like this complicated on the test? Absolutely not. You'll never see this all semester, ever. Right? It's just examples of for you to try and understand more complex structures. That's all I'm looking at, right? Otherwise, I'm just going to get boring examples from the book, and some of those boring examples don't resonate with you guys. Like, you'll look at it and go, I don't care about accounting. I have no idea. I don't care about like bookkeeping, bank accounts. Like all the book examples are around bank accounts and bookkeeping and all that kind of stuff. It makes no sense to me, and that's why I've kind of created more of a player type example. So we covered overloading operators. Am I going to test you on them? Like I said, no, but you should know what they do, right? And I kind of explained that in a nutshell there. Same thing with conditional operators. You can overload these things as well. Like, for example, you can compare a grader if one is bigger than the other one, right? It's kind of weird with vectors. Is one vector bigger than the other one? How do you know that, right? So there's ways of doing that, of course, and you have to create a whole scheme around that. Okay. So we've talked enough about this. And this is all around the sort and binary search. Am I going to get you to do a sort and binary search that's built in to arrays? No. Remember, we're going to be using lists, right? So we'll talk about lists a little bit more. Arrays are cool. It's nice to know about them and everything else, but we most often use lists in programming. We have to know how to do arrays, and arrays are very complex and confusing at times. Right? But if, for example, if you notice this array, I make an employee array, right? And it has up to 7 employees, 7 slots, right? From 0 to 6. That's what this is. And the difference between arrays and lists arrays are fixed, right? They're immutable. You can't touch them. You can't reduce the numbers. You can only change the values that are stored in the array. Whereas a list, I can add items and remove items from the list. You can't do that with an array. All I can do with an array is I can align values. I can change the value so it's 0 or 1 or -1 or something else if it's an integer. You know, I can't do much more than this. In an employee array example, either I have an employee in there or I don't, right? Inside each of the employee slots. The idea behind arrays are very simple though. The idea is it's a container that contains, in this case, employees, right? We're using employee again as a data type, right? Instead of a string or a number or double or whatever. That's how this array is being used. Will you have to do this for the test? No, I'm going to get you to do lists. Even though it looks more complex, it's actually easier to work with lists. And we'll talk about a list example today. I'll make a new one for you. Let's go back. Sort and binary search for these things. You need to use the iComparable interface. This is new. iComparable, we talked about interfaces. Here's one that is built in. The iComparable, what it does is it compares object A with object B, right? And what you need to do is with arrays is you need to create, you need to attach the iComparable interface to a particular method, or to a class if you want to compare 2 objects of that class. Okay, we're going to continue. We're going to do that a little bit. We'll use iComparable later on. Okay, destructors. Don't worry about them. Garbage collection is taken care of automatically by C#. We have rare instances where we might use this thing. I highly recommend we don't touch these or don't use destructors, at least in the beginning when you start learning C#. And in the first 3, I would say in the first 3 courses you take with C# destructors, I'm not so sure that you'd need them. Okay, so you have to understand that a destructor is like a constructor, and we're going to talk about UI in the second half. Right? So that's classes and objects. That's week 3, right? We focused a lot about class and object and inheritance, right? After that, it was just examples. From week about 4 to week 7, even today, we just did a lot of examples. So we didn't do anything really new, right? This one here, there's notice polymorphism doesn't have its own PowerPoint. The PowerPoint is up to week 4, right? After week 4, I'm just using the same PowerPoint to do inheritance and polymorphism, right? So the PowerPoint you're looking for inheritance is the week 4 PowerPoint, which is Intro to Inheritance. It should actually say inheritance and polymorphism. So if I go through into week 4, right? Again, what is inheritance? It's the ability for us to, to build a superclass, a blueprint for another class, right? And what we can do is we can have more than other classes inherit properties and methods from the superclass, the base class, right? That's what it allows us to do. Is it always good to do? No, there's some limitations with that. And the reason for that is because if I have to make changes to my superclass, all the subclasses get affected down the line, like as if it's a domino effect. That could be okay, but it can also make breaking changes that I have to go and fix all my subclasses to make them work now with the changes that I made in my superclass. And that can be okay if you have a small program. Even the one I made, this player example, is a small program, right? But if I have a really big program, like a large program with lots and lots of classes, and that depends on everything else, one change in the superclass in the wrong place will break your program. It's a breaking change that'll stop your program from working. And that's why we want to avoid inheritance, to use it all the time. It's not something we want to use all the time. It's better to use, like I said before, class composition. All right. And remember, when we make a diagram, the arrow always points to the superclass object. So if I have a commission employee in this example, and I have an employee, which is a superclass, right? As an example, we're making the commission employee, which is a specialized form of employee, point to the base class employee. Now remember, I asked a question on the quiz last week, which was, if I have a subclass, is the subclass bigger or smaller than your superclass? And the answer is always, always, always that your base class is smaller than your derived class or child class. Always. Superclass is smaller than your child class. Why? Because the child class is a specialized form of the superclass, which means there's extra stuff in it. I'm extending my superclass. I'm implementing interfaces, right? Those are the 2 words you have to understand. So if I put it on your assignment, it says, extend the superclass blah, 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 and make a child class of this, that means here's a superclass. I'm going to make a child class over here, and this is what it's going to be. That's what it means. If I say implement this interface, right, it means this interface that we've defined has to be, the method that we've defined in the interface has to be inside of our class where I'm implementing the interface. That's all. It kind of continue creating the shape for our classes a little bit more. Because we don't have, ever in C#, Java, and other languages that are C style oriented, we do not have multiple inheritance. We only have single inheritance. It's only one parent class for each child class. There isn't 2 parent classes. It doesn't exist in our paradigm, right? Okay, so we just talked about these base classes and derived classes. You should know about them. You already know the verbiage, the things we've been talking about all the time, but you should know how to create a base class and a superclass and a subclass by, here is the subclass, commission employee, and we use the colon to indicate what the superclass is. So this is the superclass or base class, and this on the left-hand side is the derived class or child class. Okay, that's what this is. When we do that, everything that was existing in our employee class is now part of our commission employee plus new stuff, which means our child class is bigger, is fatter than our parent class. It's always that way. Okay, just to let you guys know. That's how we extend classes. It's all around, that's what inheritance is all about, actually, extending our classes and making them bigger. We can also use something called the protected keyword. And do I want to use things? I'll tell you right now, I usually try and avoid using protected keywords all the time. Protected, whether you're using a protected method or a protected data field, I want to try and use that as sparingly as possible. I should have public methods that even my child classes are using. Public methods and public properties that my child classes are using. I can do that. I always want to continue and encapsulate everything from my superclass so that everything is protected. Like everything is not the protected keyword. Everything is hidden from all the other classes, even my child classes. Could I expose them? Yes, I could. I could expose fields that I want to use directly if I want direct access to a field. And this is bad. I highly recommend against it. But direct access to a field with a protected keyword, yes, you could do it. Should you do it? No, you shouldn't. You should use a public property all the time, right? Why? Because when we use protected or private directly, we take away control when I assign values. That's the reason, okay? Whereas if I use my getter and setter, I have more control. I can add more things in there inside my accessor methods, right? As opposed to directly accessing them, right? So we want to try not to directly access anything ever, okay? Well, can I keep going down here? So protected. Am I going to get you to do protected stuff in the test? No. I just told you not to do it. So I'm not going to ask you to do it in the test, right? Overriding base class methods with polymorphism. The only base class method that I'm going to get you to override right now, I'm not going to get you to override some of these right now. The only one I'm going to get you to do is the built-in base class method toString. That's because of our main object superclass, right? I'm going to get you to override the toString method, and that comes down further down into our PowerPoint. But overriding base class methods, you need to use the override keyword, right? And then the name of the method that you're overriding, right? Do I have to do this for constructors? No. That's the only time you don't have to use the override keyword. You automatically override when you just name the constructor again. Okay, so be careful about that. But I could override a property. This is a property, right? And the property that I'm using is an accessor method. For my set accessor method, I can override it for example, for my scholarship student, right? Which is a subclass of the student superclass, right? I could create an override just for the accessor method for the setter. That's weird that it only has a write to and there's no getter. That's like a write only, right? Which is weird. It's almost never happened like this. Okay. And there's some other examples here as well. Will I get you to do that on the test? A strict overridden method? Probably not, right? Could we do it? Yes. If you have to use the override keyword to override methods of the superclass if you need to make a specialized form of the method compared to what the base form is. But if you're doing that, if I'm overriding my superclass method all the time, then I might as well make it abstract. We'll talk about that. If I'm always going to override, if I always override my base class method, and I'm doing it a lot in my subclasses, I might as well make it abstract because I'm just going to make it my own anyway, right? So I shouldn't make it concrete. Let's talk about this a little bit more. As I move forward, I want to make sure reference conversions. The idea of is a object is important. It has a relationship with its parent class. We'll talk about that a little more. Here's what I'll talk about here. So using the object class, the only things we're going to use from the object class, like I said, that you're going to override, that I will ask you to do 100% is the toString method. Please understand how to override the toString method. Remember that the toString method returns a string. So if you want to try and pump it out to the console, you have to do console write line, whatever the object is called, .toString. Otherwise, you won't see it. Okay. An example of that is what we did earlier with my grid. Here's my grid. My grid has overridden the toString method. The toString method by itself does not pump everything out to the console, right? I have to use a console write line to wrap my grid.toString method so that it prints to the console, right? I could print out everything to the console before I return my string. I could do that too, right? But the clean way of doing it is that the toString method takes whatever you assign to it, the object you're assigning to it, now that I've overwritten it, and it'll pump it out to the console. Here's also something that I've done. I can also I've also overridden my vector objects toString method, so I can see a clean position number like x and y coordinates for this example. So let's say, for example, I want to know the green player's position. I could do something like this. I can say console write line, right? Green player dot position dot toString. I want a nice clean example of what the position of my player is, right? And if I do that one day when it updates and I play it, oh yeah, it's taking its sweet time, right, to upload. Okay, if I play this now, you can see that down the bottom it says, here's my position, 6'5". That's my new position for my player, 6'5", right? So it gives me a nice clean. I created that. It didn't come. There is no vector2 object, right? I made my vector2 object and I made my own vector2 toString. I overrode the toString method, so it shows you a nice clean way of showing the position. That 5, so it goes 6 across and 5 down. That's what it means, right, for my player object. Originally, it started off, remember, my player didn't start there. My player started off, if I look at my player position, at 1, 1, right? And then I moved it around, so it's now at 6, 5, right, which is the graphical representation we're seeing here. By the way, I can't wait till we get to the next half of the semester, so I don't have to do console anymore. We can actually use real objects. I can actually use some UI. I think it's better for learning, honestly. When we use a UI, you can put objects on the UI to do stuff with, and it's a lot better than just using this kind of stuff. Okay, so move right, move back, all this kind of stuff we can do. But that, like I said, it all has to do, the only thing I'm getting you to override is the toString method. GetType is something we want to know how to use, and I've only used that one time. So I want to know the type of my class. Which one is it? Which object is it? Is it a player or an enemy? Which enemy is it? Is it the shooting enemy or the touching enemy? I can use getType, so whatever my enemy is. So let's say, for example, red enemy dot getType dot name, and I can know which enemy it is, right? And what it does, identifies the actual data type, if you will, of that object, right? And type, in our case, means which class is it? Is it the shooting enemy or the that kind of stuff? Will I get you to do this on a test? Maybe. We'll see how it goes. I don't know. Depending on how many extra things I get you to do, I don't know if I'll have time to do this. Definitely toString. You'll definitely have to override 100%. You'll have to override the toString method. Please know how to do that. If you don't know how to do this, you just lose marks on the test. Okay? You want to have a proper output. Okay. We're not going to talk about this. We just talked about it. And this is the getType method. But getType by itself, it refers to both the superclass, as an example, or the name of your namespace plus your class, which you don't need. All you need is the name. Okay. Equals, we're not going to get you to use if one equals to the other. And we're definitely not going to use get hash code. Get hash code gives you a unique identifier for each of your objects. It's nice, but unnecessary for us. Okay, so we're not going to do that. Working with base class constructors, we just talked about that in our method. And here's a good example of that. I have my employee superclass, right? And I have my commission employee subclass, right? And here's my employee superclass's constructor. Both constructors for the employee and the commission employee are empty constructors, right? Both empty constructors. Therefore, do I have to do anything special and send anything back to my superclass? No, not in this case. But what happens if, as an example, I'm down here and I want to send over some information that my superclass requires? For example, it might require some kind of number and some kind of string. Well, that means I have to use the :base keyword to send this stuff back to the superclass constructor. And here's an example of that down in here somewhere. Abstract classes and abstract methods. Abstract class, remember we talked about an abstract class. We did an example of abstract planets for your assignment number 3, right? Abstract planets that you're doing right now has a planet blueprint, and then you have abstract planets, which means you have, for example, a terrestrial planet and a gas planet. Both kinds of planets, they still have an is-a relationship. It is a planet, but the abstract class itself can never be constructed by itself. I can't make an object of an abstract class. I can only make objects of my concrete classes that are derived classes of my abstract class. So that's one of the things. You cannot create concrete objects of your abstract classes. Abstract methods have no method statements. And like I said before, if I'm always overriding, if I'm constantly overriding, and every one of my subclasses is overriding a method, I might as well make it abstract, because that means you're going to override it anyway. So I'm not going to even put the statements inside. I'm just going to make the header, which means you need to have this method, but you need to define it in your subclass, right? That's what it means. Am I going to get you to do abstract methods? No. Not because I don't want you to. Just there's too much to do in a test, and there's not enough time to do it all. And this is what an abstract method would look like. Notice that there's no code block. It's just the method signature. And when I assign an abstract method, I must override in my subclass, right? So which means I need to use the override keyword here, right, for the speak method. Example of this would be, here's my abstract method speak. I don't define the actual method itself in my abstract class, and down in here I must override in the subclasses. If I've defined an abstract method, I must override. Okay. Abstract classes. I want to talk about those a little bit. Interfaces. Will you have an interface to use for the test? Maybe. I'm still playing with that thing, only because it can be confusing. What are interfaces for? What are interfaces for? What do I need them for? I has moons and I has rings, yeah. Right. Yeah. So what they do, the interfaces, what they do is they help us. We actually make a contract. That's what it does. And it's a contract between us to use the methods that are built into the interfaces that are defined. The method headers that are defined in interfaces, it's our contract. When I say I'm going to implement this interface, it means I'm going to shape my class, that I'm going to add this method to change the shape of my class. That's what I'm saying. I'm almost like promising. I'm promising that I'm going to use this method. That's what I'm doing. Now you might say, why would you do that, right? And this is the biggest, understanding problem with students. Why would I ever use an interface? Because for us and our small little examples, even for this big player class that we made or whatever, or even abstract planets, meh, who cares whether we use it or not, right? But in a larger example, if I'm passing information, let's say to Joanne, right? Joanne and I are working, she's part of my team, and I'm creating the superclass, and I want every user of my superclass to implement, as an example, some interface that I want, right? Or some method. And I always want them to override it. I always want them to define their own method. I don't build it in. It's not an abstract method necessarily. I want them to use an interface. I can do that. I can create interfaces, and then my subclasses may have to use these interfaces to create the shape that I want for my class so that it plugs in properly from a business requirements perspective, so that it makes sense to the real world. Because remember, I'm trying to map my classes and my code so it maps one-to-one to what I see in the real world. Can I do that every time? Absolutely not. I have to try, right? And so interfaces are a way of adding an additional shape, a shape for a class without using multiple inheritance. Yeah.
So you can treat as many types of interfaces that you want, and basically that class can pick.
Yeah, you can decide. You can right. You can say you can almost like describe your class, the subclass as an example, or even a concrete class that has or does not uses or not uses an interface. Now, sometimes we use interfaces with classes that are built into C# or that are built into an API, an application programming interface that's defined in C#, right? Like, let's say, for example, we want to use an interface. We need to use this interface because it's defined as a requirement, I don't know, to do some kind of data access with a database. I need to use this interface. My class has to extend or implement this interface. I have no choice, right? Sometimes it's accessibility. Sometimes it's creating a method or properties or whatever, giving extra information in the interface, that basically defines the shape of my class. That's all it does. And I want you to think of it this way. It's a contract. When I implement that interface, if I use the colon, and next to the colon, there's two ways. Like anything next to the colon is either a class or an interface, right? And I can use the comma to separate my class, extending my class, and then my interfaces. By the way, it doesn't matter which way you do it. I can implement my interface and then comma extend my class, or I can extend my class, comma, I can implement my interfaces. And I can have as many interfaces that I want to implement as I want with comma separated values, right? That's what it does. Will I make you do interfaces on the as an example on the test? Yeah, there might be one. I'm telling you, like one. Like it might be one interface that I might make you make, or two. I won't make you make too many, and it's really just to understand how to use them in the test. And we don't have a lot of time. We have 90 minutes to try and get everything working for you guys. That's gonna be a real challenge on its own, because you're gonna see my code, it's not your code. So right there, it's a big challenge, because you're seeing somebody else's code. You're looking at it going, this isn't my code. I don't structure my code this way, right? How do I do this? What do I plug in here? I wouldn't do it this way, because I'm getting you to program like me, right? That's not easy to do. Even if I try and tell you, put all this stuff, I'm gonna have some comments. Like there might be a comment block that says, fill this stuff in here from part two. Part two says, I'll put a comment in that says, put the information in here, do that, right? Yeah. Correct. You just fill it up, make the methods work, right? Now that's great, but the problem with that is that people are like, well, I wouldn't write it that way, right? That's not, I'm not, Tom, I'm not you. I'd write it differently. And I'm going to tell you where things you can change and things you can't change, right? For the most part, I'll allow you to change whatever you need to change to make it work, right? But I will suggest, you know, the best ways of doing it. I'll say, here, fill in the blanks here inside the template, and then this is what your output should be. Your output should look like this, right? I'll try and give you an example output. Okay, so interfaces. So again, a lot of work on interfaces. I don't think we're going to do too much on interfaces on the test, only because you've got an assignment for that. And right now, because they're so small, the stuff we're using, there doesn't seem any need for it. Also, extension methods. I'm going to put it in there for you guys so you understand. They're there. We haven't really talked about them too much. And the reason for this is because, you know what? We use extension methods very sparingly, right? So, and if you notice, look, it's like one slide on extension methods. Am I going to include it in your test? Absolutely not, right? So that's the stuff I'm going to include on your test. Let's talk about lists. That's one thing that's not in your PowerPoints. And I think it's important for us to know what a list is. So again, I would refer you back to the documentation about lists for C#. So if I go list C#, right, like this. If you look at the list class, which is on MSDN, so it's the Microsoft application programming interface for C# for list. This is where I want you to look, right? Notice that it's system collections generic. What makes it generic? The less than and greater than sign, also called angle brackets. Anything in the angle brackets, where you see a T like this, T means type, right? So I can create a list of a type, list of strings, list of integers, list of cards. Uh-oh. You know, I'm telling you, these are the things I can do. List of commissioned employees, list of whatever, right? The T stands for type. So when I instantiate a list object, right, this is the class. I'm getting you to use a class that's built in, right? This is the test that you'll definitely have, all right? I'm getting you to use a class that's built in called the list class, right? It takes a generic type that you have to define. An example of that would be, if I go down here, yeah. No, I'll give you the shuffling thing. I might give it to you and say, use this shuffling. It works. I tested it. Use it, right? But I won't get you to shuffle on your own, right? There's too much. Again, you only have 90 minutes. You have to create your classes, make sure they work, test them out. So doing the Fisher-Yates shuffle and all that kind of stuff, you can use it. And remember, even if I ask you to use it, I might refer to where you can see it, right? Because remember, you have access to everything, access to GitHub, access to, it's open internet, open book, open everything. Just please don't look at my videos. That's it, right? So it's not going to stop you from looking at stuff. The other thing I'd ask you not to do is please don't, don't talk to anybody in the test. Yeah. Just a pain in the ass. Yeah, it's just going to waste your time. I mean, if you really wanted to look at the videos, okay, go ahead. But you don't have time. There's no time, right? Like you only have 90 minutes to create something. And I know I've seen people look at the videos in the past and they've just barely finished. Some people look at the videos and they're like, I didn't finish. I was watching your videos and it took me forever because I didn't know where I was looking in my video. Don't do that, right? Look at the GitHub examples. That's faster for you. Practice, you know. The other person asked me, hey, can I use a template of my own? There's another question I got on my test. I have my test as an example, and I also have assignment 1, 2, 3, right? Could I use assignment 3 as my template for the test? Well, as long as it meets my requirements, I don't really care. And that's why it's open book, right? And it has to be named properly. Your test for your exam or test, for this one and for anything else you do with me, the test itself, the project has to be named in a certain way. If you want to make a template based on your assignment 3, that's okay. But you have to name it with the name of the test and then your student number, right? So that's going to be required. If you don't do it that way, it's not acceptable. Let's take a look at this. Here's a list. I'm going to go back to list for a second. Here's some things how we construct a list. The constructor for the list is kind of weird. It has these angle brackets. And if I click on this, if I click on the constructors for the list, it gives you some really cool examples of how to look here. This is where I want you to look for your test. If I ask you to do a list, here's some great examples of how to initialize a list. A list of strings called dinosaurs. Okay, here's a good example. This is right online, guys. All right. I used to use the new keyword because the list is a class. right? Just like we've been doing. So one part is making your own class, and another part of the test is using somebody else's classes, which are built in. This list is just an excuse for me to get to use somebody else's class, the list class, and instantiate an object of something you don't have control over. This is something that's been created by somebody else, by Microsoft, right? So now I'm going to use the new keyword, a new list, and I have to, it's like this side has to equate to this side. So if I say it's a list of strings, on this one I'm going to create a new list of strings, and I have to use the open and close brackets. If I do that, this is the syntax you need for a new list item, a new list object. Here, when I have my new list objects, I can use the add method that's built into all lists, because in the list class we have something called an add method, right? The add method allows me to add in strings, right? The type that I defined up here. It allows me to add in strings to the list. I want you to think about a list as, you know, something that when I use the add, I append another item to the bottom of the list. When I use the add method, I just add another one, add another one, add another one. I keep adding as many as I want. I can also remove a specific item. Add and remove are built-in methods that are part of all lists. Will I get you to do a lot of removes? Probably one, right, with what I'm doing. Probably I'll get you to remove. So I'll add items to the list, and I'll remove items from that list. Okay, we'll talk about that. Okay, and then the best way to cycle through a list, to iterate through a list, is with the for each method. The for each iteration, method, or the built-in for each statement here. What it does is says, hey, for each dinosaur in dinosaurs, right? I want you to print the dinosaur out to the console. So this is the best way. Could I do it another way with a for loop? Yes, you could. For I is equal, or index is equal to 0. Int index is equal to 0, starting off at 0, where index is less than whatever the list name is, .count, because count is a method, or a property that's built into lists. All lists have a count property, almost like a length, right? And so it counts how many members are in the list, right? So if my index is less than whatever the list name is, .count, dinosaur.count, or whatever, then index plus, and you can rifle through each of the list items like that. Remember that even though it's a list, you can still treat it like an array. You can still use square bracket notation to go say, hey, list item 0, list item 1, list item 2, and so on. You can go through the list as if it's an array as well. So keep that in mind, please. That's why we use lists, because they're so flexible. They're more flexible than arrays. Arrays are immutable. You make an array, it has to be a certain length, never changes. You can change the stuff inside the array, but you can't change the length of the array. The arrays are fixed. Lists are fluid. Lists, you can make a list that's add items to the list and remove items from the list and so on. It's more, flexible in that way. Okay, so that's lists in a nutshell. But remember that lists have built-in methods. And the main methods we're going to use on the test are the add method to add items to the list, right? And the remove method. Here's the remove method down here. Let's take a look here. If I scroll all the way down to the bottom, here's the remove method, right? To remove items from the list. What about the sort method? The sort method. I could use the sort method to sort items in the list too. If I click on the sort method here, I might ask you to do this too. For bonus points, I might say, hey, sort the list into alphabetical or ascending order. I might ask you to do this. The answer to that bonus question is right here. If you look at the how to use a sort, you take the name list. Here's names, a list of names, right? And here's my name list, which is a new list of strings. That's what it is, right? And what I'm doing here, notice how I'm using the var statement. Remember we talked about the var statement briefly. It's more of an advanced method, okay? I want you to think about this. It's almost like I'm using implicit variable declaration as opposed to explicit variable declaration. Implicit means whatever I'm assigning to it, the compiler decides what type of variable it is. So it says, hey, let's take a look at the right. Well, on the right-hand side of the equal sign, it's a list. Therefore, name list is a list, right? So I use the var keyword to do that, and it looks very similar to JavaScript, right? Actually, if anything, this notation is very popular in C#. If you look up online on C#, you'll see this notation all the time. But what's another way to write this? List of strings called name list is equal to a new list of strings. Same thing, right? And then what we can do is we can add our range of names. Here's our names, right? And add range is an interesting method. I never really talked about it for lists. That's something of an advanced method. What it does is it defines a range. Here's an array of names, right? And I take these names and I add them onto the list right away. It's a way of initializing the list by using an array and a list, okay? We're not going to get you to do that. But now if you notice, as I go down, I can use the sort method of the list to sort everything in alphabetical order, sorted order, right? So if I want you to sort anything for the test, you're going to use the sort method built into lists. If you were trying to sort an array, it would take you all day. They would try to figure it out. If you haven't done it before, not all day, but it's a lot more. It's more difficult. You'd have to have two arrays, your initial array and your second array. You'd have to kind of look through each of the items in one array and then sort it and kind of create the second array with sorted values. Then take those sorted values and copy them back to the original array. And it's a lot of work, right? Here we don't do that. We just use the sort method and it sorts everything in alphabetical order. So please, if I ask you to sort something, and I probably will on the test on Friday, sort method is the way we do it. Okay. You can also convert something to an array with a list. Like if you want to take a list and convert it back to an array, it returns a new array. That's what it does. If I use the toArray method, I'll never get you to do this, by the way. But just as an interesting point is, here's my dinosaurs array again. Here's my string, and I have a string array of, as an example of, I'm instantiating it with Brachiosaurus, Amargosaurus, and this other one. These three different dinosaurs. I'm making a list of dinosaurs, right? And I'm kind of initializing my list of dinosaurs with the add range method. Here's the add range method. But after I'm done doing everything else, what I want to do is I want to convert it back to an array, right? Well, down in the dumps down here, you can see where it takes the list and converts it to an array right here. So I can say my new output array is this, whatever the remaining list is, and then convert it to an array. And it'll actually create a new array based on the list. Neat, but will you need to use it? For me, no, right? So remember that everything we're going to do with the list is here up online. And I would refer you to this MSDN document. This is the link for it, and you can see this in the video for lists. You can also just search for list C#, and everything you need is right here online. You'll have access to it during the test. And remember, the only two things that I'm probably going to get you to do, or the three things, are add, remove, and sort. That's it. So if you know how to do those three things with lists, you're golden. Let's take a short break. When we come back, I'll make a new project, and we'll make a short list of names, and we'll use some of those functions, add, remove, and sort. All right, so we'll try that. Also, I want to also hit random numbers, because that's another thing that's definitely going to be on the test, right? And I want to make sure that you guys understand how to do that. Okay, let's take a short break and come back and talk about that.